welcome students. I'm Mr. Michael, your revision master of chemistry, and I teach chemistry at Nasokol Girls in West Pokot County. Now today I want to take you through qualitative analysis, which is normally tested in chemistry practical, that is chemistry paper 3. Now, qualitative analysis is an analytical technique that aims at the determination and identification of substances. Now, it's divided into two. We have what we call the test for anions and cations and test for functional groups. Today, my presentation is mainly going to be focused on the tests for cations and anions. And to be more specific, we are going to carry out or to be taken through a series of activities that will lead to identification of the sulphite ions. And this was question 3 of paper 3 of KCSE 2003. So I will use just the question that was tested in KCSE that year to take you through a qualitative analysis. Now the question was that you are provided with solid V, so you carry out the tests below and record observations and inferences in the spaces that will be given. So the first thing that you were told to dissolve solid V in 20 cubic centimeters of distilled water in a boiling tube. Then in 5 separate test tubes, put 2 cubic centimeters portions of the resulting solution and use it for tests that follow. So whenever you are told to add water to a solid, majorly the examiner wants you to test the solubility of that solid. So you should find out in your observation whether the solid dissolves or not. And what happened that year was that the solid dissolves to form a colorless solution. That is what happens when learners put the solid in the boiling tube and added 20 cubic of distilled water. It dissolved, they saw it, and it formed a colorless solution. But that is what was observed. So whenever a solid dissolves in order to form a colorless solution, what should you write as the inference? That means the solid is soluble. So that the inference that matches this observation is that because it dissolves, solid V is soluble. Solid V is soluble. Remember, soluble is always an inference, not an observation. That one is an inference, not an observation. Then another inference that you can give, it forms a colorless solution. If it forms a colorless solution, that is what you have observed. One of the things that you should infer. Of course, it means colored ions are absent. And the colored ions are normally the copper ions, the iron 2 ions, and the iron 3 ions. In short, you can say kufefe. Kufefe is absent. So this one is tied to the colorless solution. So you write that copper ions, iron 2 ions, and iron 3 ions are absent. Now, the students of that year, they were told that to do this in the second portion, to add 5 drops of sodium hydroxide solution. And they did. And normally, as students should know that whenever you add sodium hydroxide solution to a substance, you expect formation of a white precipitate or no white precipitate. But now for them, when they added sodium hydroxide solution, there was no white precipitate. Of course, when performing the experiment on addition of sodium hydroxide, it will just be a colorless solution. But because the expectation is that you'll expect formation of a white precipitate, and you don't see it, so you write the observation as no white precipitate. And when you do that, that means there is no ion that can form a precipitate in that solution. And there are a number of ions that normally form precipitates with the sodium hydroxide, including the zinc ions, the lead 2 ions, magnesium ions, calcium ions, and aluminum ions. So it means all those ions that are capable of forming white precipitate with sodium hydroxide are absent. So that is what you write as the inference. Now to the second portion. Add 3 drops of lead nitrate solution. Lead nitrate solution is used to test for anions. And whenever you add the nitrate solution, of course, you expect a white precipitate. You expect it to form a white precipitate. And if you don't see a white precipitate, then you don't write that no white precipitate is formed. But now, for those reasons of that here, when they added lead nitrate solution to the second portion, there was a white precipitate. A white precipitate was formed. And whenever a white precipitate is formed, that means an insoluble salt of lead has been formed. It's an insoluble salt of lead because you added lead nitrate. And remember, lead nitrate consists of lead ions and nitrate ions. So when you add and you see a white precipitate, it means these lead ions have reacted with certain ions and formed an insoluble salt of lead. And the insoluble salts of lead include lead sulphate. So that's why we put sulphate as one of the inferences. Another one is lead sulphite. That's why one of the inferences is sulphite ions. Another one is lead carbonate. That is another insoluble salt of lead, and lead chloride. Those are insoluble salts of lead. That is why now our inference will be sulphate ions, sulphite ions, carbonate ions, and chloride ions present. Remember to use the formula of the ions, not their names. Now, the second, to the third portion, the learner was told to add barium chloride solution, followed by 5 drops of dilute nitric acid. Barium chloride, instead of using barium chloride, you can also use barium nitrate. You can also use barium nitrate instead of barium chloride. So when the learner was told to add barium chloride solution, followed by 5 drops of dilute nitric acid. So here the observation that you write must be in 2 steps. The first step is when you add barium chloride, and the second step is when you add nitric acid or dilute hydrochloric acid. Any of them can be used. So when the learners added these, what they observed was a white precipitate which was soluble in dilute nitric acid. And when you see a white precipitate formed on addition of barium nitrate or barium chloride, and that white precipitate dissolves in a dilute acid like nitric acid or hydrochloric acid, then what you write as the inference is carbonate ions or sulphite ions present. Then to the fourth portion, add 3 drops of acidified potassium manganate 7, which is normally a purple solution. This potassium manganate 7 was actually, its role here was to differentiate between between carbonate and sulphite, so that we find out between sulphite and carbonate which one is present. So when the learners added acidified potassium minus 7, they observed the purple color of acidified potassium minus 7 changes to colorless. And when that happens, it means the inference that goes with that, goes with the name of carbonate and sulphite. Now it means sulphite is present. But if the purple color of acidified potassium minus 7 had persisted, then the inference should have been carbonate ions present. Or also, another solution that you can use to differentiate between carbonate and sulphite is acidified potassium dichromate 6. Now, so the learners were told to the fifth portion to add acidified potassium dichromate 6, and when they did that, the observation was potassium dichromate 6 changes from orange to green, implying that sulphite is present. However, if the orange color of acidified potassium dichromate 6 had persisted, what the learner should have written as the inference is that carbonate ions present. So you can see from all this series of events, we can see we have been taken through steps until we have identified that the solution prepared by dissolving solid V in water contained sulphite
iron. So remember to subscribe to my YouTube channel so that you can be notified when I upload another video, and also like my channel.